analysis Vitalism lab. Remember, in this lab I have measured the carbon dioxide level in two chambers. One had glucose solution and yeast extract in it, and the other one had glucose solution and boiled distilled water in it. I tried to show you that carbon dioxide gas will be produced in the first chamber, and result is not caused by the something in water other than the yeast extract. When I look at my data, I see that there is increase in carbon dioxide level in both chambers. There's a better change in here and less, very small change in here, but I want to prove that this is a result that is not statistically significant. And I will apply a chi-square test for chamber 2 to show you that the change in the carbon dioxide level is not significant statistically. So how do I do? There is a two tests for chi-square. I will do the goodness of fit for my idea. Again, I want to know if the change in the carbon dioxide level is significant. Firstly, I will form my two hypotheses, one null hypothesis and the other one alternative hypothesis. Null hypothesis would be there is no statistically significant difference in the carbon dioxide level measured in the chamber 2 and the expected carbon dioxide level in chamber 2. And alternative hypothesis, there is statistically significant difference in the amount of carbon dioxide measured in the chamber 2 and the expected amount of the chamber 2. That means null hypothesis. If I accept this hypothesis, that means that this change, very small changes in the carbon dioxide level, is not statistically significant, and actually there was nothing going on. There was no fermentation or other change in sugar in the chamber 2, so there was no chemical reaction happening here. And I will do the same thing for this change. If that shows, like if I accept a null hypothesis for this, that also means that there's no significant change in the carbon dioxide level and there was no chemical reaction happening here. But if I reject the null hypothesis, that means there's something happening here other than regular. So these are my null hypothesis for the chamber 2. Now next, what I'm gonna do, I have my entries here, like observed values, but I don't have my expected values. This is the formula for chi-squared. As you can see, it's the summation of observed values minus expected values for each entry and square of them, and then divide them by the expected value for each entry, and then add them together. Summation of each entry's calculation. So I don't have an expected value. What people usually do is they get the average of these numbers and put it as expected carbon dioxide expected value. In this case, it's the expected carbon dioxide level. What I'm going to do is I'll go all the way down, click this cell, hit AutoSum, which is the summation of all the entries, which is this. And then here in this cell, what I'll do is I have 116 entries, so I will divide this number by 116 so that I will get the equal this number divided by 116, so I will get the average of these here. So it's 1138.6 I will do, because I have in each cell, I have, these are formatted, these two are not formatted. So in each cell I have one decimal, so I will round it to the one decimal. 1138.6. 1138.6. So this is my expected value. I will not enter the same numbers on each cell. What I'll do is I'll move my cursor to the right bottom side of the cell, and when I see this cross sign, I will just hit click and then drag it all the way down. It will copy all the numbers. That's it. Now what I'll do is I will need a critical value so that I can compare my chi-square value to a value. Accordingly, I will accept the null hypothesis or reject the null hypothesis. If the chi-square value is higher than the critical value, then I will reject the null hypothesis. If it is smaller than the critical value, I will accept the null hypothesis. To do this, I need two things. One, to be able to find the critical value, I need degree of freedom and the alpha value, which is the significance level of my test. I will pick 5% significance level, which roughly you can say I'm doing this part of the test with 95% accuracy. 95% accuracy. And the degree of freedom is, so this is 5%. However, right, the 5% is 0.05. This is 5%. And my degree of freedom is number of entries minus 1. What is the number of entries? It's 116 minus 1 is 115. So let me write here degree of freedom, it's 115. So I have my chi-square table here. There is a part of it, I copied this from a website. Degree of freedom is 115. The alpha value is this. So my critical value is 141.03. 141.03 here. 141.03. Right, now I will calculate my chi-square value. Here's the formula for the chi-square value. What I'm going to do, I will hit this hit this cell, click equal, and then parenthesis, my observed value, which is this, minus my expected value, which is this, parenthesis, and square this value, put a cap here, and then 2. That means it's going to take the square of it. Divide this value by my expected value again. When I hit enter, I will get the result. This is not my chi-square value. Summation of these is the chi-square value. So what I'm going to do, I'm not going to enter the same formula for each cell. I will again move my cursor down the right bottom of the cell. When I see the cross sign, I will drag it down, all the way down. There you go. I have all the calculations. What I need, summation of these numbers. I will just hit auto sum and enter. This is my chi-square number. Chi-square. Calculated chi-square. There you go. Let's format this to the nearest on Earth. There you go. Alright, this is for the chamber number 2. What I see is my chi-square number is lower than the critical value, which means I will accept the null hypothesis. What null hypothesis tells me there is no statistically significant difference in the carbon dioxide level measured in the chamber 2 and the expected carbon dioxide level in the chamber 2, which means the change in these numbers is not statistically significant, which indicates me there was no chemical reaction going on causing any change on carbon dioxide in the atmosphere. These fluctuations probably the way the machine work. Alright, now I'm gonna do the same thing for the chamber 1. I will just clear these to not do the same tables again. I will clear these. Now I'm doing the same test for the chamber 1. First, I will calculate my average. The average is equals this number divided by 116. This is the, I will say 1649.3. 1649.3. Alright, this is my expected value. Drag it down. There you go. Now I will calculate the chi-square value for this. So chi-square for chamber number, oh, I did the same, wrong thing, I'm sorry. Let's do this, chamber number 2 and chamber number 1. Alright, now how I calculate it? Observed value, that's equal parenthesis observed value minus expected value parenthesis squared divided by expected value. Enter. And I will drag this down. Before doing this, what is my degree of freedom? 115. What is my critical value? Alpha value? 5%. What is the critical value? Is 141.03. 141.03. 141.03. Now I can calculate all these. Drag it down to apply the formula for each cell, and then summation of these numbers is the chi-square number for me. That's 239.4. 239.4, which is way higher than, almost twice, way higher than the critical value in the table. So what I do, I will reject the null hypothesis. What null hypothesis tells me? It tells me that there is no statistically significant difference in the carbon dioxide level measured in chamber 1. Because I'm doing this test now for the chamber 1, I just didn't want to make the same table twice. Okay, there's no significant difference in the carbon dioxide level measured in the chamber 1 and the carbon dioxide level and the expected carbon dioxide level in the chamber 1. So as you can see, this change is pretty significant, indicating that there is something happening like different than usual. Glucose is not just sitting there, it is being broken down. According to our idea, they are being broken down by the enzymes extracted from the yeast. Thanks for watching Harmon Public Schools.